Yeah, I don't know. So anyways, let's get started. So let's start with the notes as the notes. All right, so we're going to be talking about Newton method. So in this section, we're looking at something called a numerical root finder. Basically, it's a way to approximate zeros. 90% of the time when you are solving equations, what do we want? We want zeros, right? We want the zeros to find critical points. We want zeros to find points of concavity. We want, for optimization problems, we wanted the critical points, right? Um, when you're solving polynomials, you really care about zeros. Knowing the zeros is for polynomials or any function for that matter is just super useful. And so Newton's method is just a way of kind of finding that. We almost never do these by hand, but you're going to do a couple by hand, but they're usually done by on a calculator. So this is what your calculator does if you have like a TI-89, which I'm going to grab for 1 second. I have no clue why TI-89s are still $150. That's what I paid for them when I went to college, and that wasn't yesterday, guys, right? The technology in them is not that new, right? And I'm like, why? Why is this so much? And then I realized it's not a technology product, it's an education product, and it has that education tax on it. Same thing with um, photo umbrellas. It's like an umbrella is like $10. A photo umbrella, which is no difference in material and actually sometimes worse made, is like 50. I'm like, it has that photographer tax on it. Or a computer algebra system. So what's a computer algebra system? Well, we've been using one, right? What's our computer algebra system, right? The one we've been using for this course is this one, right? Wolfram Alpha. It's computer. This is a computer algebra system, and this is the things like if I type in, where is x minus 4 to the 30th minus 6x to the 43rd plus 7x equal to 0, right? This might be a bit ridiculous, right? There's the solution, right? Well, how to calculate that? Well, yeah, this is what it did. We won't get into that. There's lots of complex solutions. But we're going to look at the one real solution, right? There is a real solution. And so where's it getting this from, right? Where's it getting this mess from? And how is it calculating that? And so this is a computer algebra system. We call them sometimes called CAS for short, CAS. And so we're going to learn how, I'm not going to lie, we're going to learn how old computer algebra systems solved it. Wolfram Alpha is using something more sophisticated, right? Like how WebSign costs $100. Yeah. Yeah, I'm aware. I'm aware. But unfortunately, the department says I have to use such things. So they choose the book. I'm not high enough to choose my own book or anything. When I teach real upper division class, I can, but not for this stuff. And I get it. They want everyone to teach from the same book, because if I taught from a book I wanted to and didn't use WebAssign, then you went to 182 and they taught from a different book and did use WebAssign, it's just not consistent. So I get exactly why they do this. Okay. All right. So we're going to focus on Newton methods. Newton methods, it says, given a close to a root or a 0, we're going to find the tangent line of that point. So the tangent line of that point is just given by this. This is the equation for the tangent line. This is what we did before, right? So given a point, so given any curve, so we're going to have some curve out there in space. I literally left myself space for this. I thought I had. So here we're going to have some curve out in space. And so I'm going to say this is the one where it works. I'm going to say this is the one where it doesn't, right? And I'll show you how it can fail in a second. So given any point, so we're going to have some curve out in space. Right, and here's some, and I'm going to choose some point. Let me make my curve a little bit more. All right, and I'm going to choose some point here. And I'm going to call this x1, right? And this point right here is the function at x1. And so here we have a point x1, the function at x1. So I have some point, and what is the slope right here? The slope of this line. the slope of this line is the derivative, right? Is the derivative, right? And so here I'm just taking, all I've done is given some x1 close to my 0, right? This is my root right here, close to my 0. I'm just going to find out what the function value is, figure out what the tangent line is, and then I want to figure out where does this tangent line hit the x-axis, or when is y 0 for this tangent line, because this tangent line should mimic what the curve's doing, right? And so I just set this equal to 0, and then I just solve, and then wherever this hits, this is going to hit at some x2. And so here I'm plugging in a point, 0, x2, so I'm plugging in the point 0, or x2, 0, right? I want to find x2, 0 on this line. Well, how do I do that? Well, I know this is 0, so I just solve for x2, and so I get this. This is just solving this. And so I get a point, and this point is closer to the root than this point. And it's like, okay, so what do I do now? Well, I figure out at x2, I just figure out where is this point? What's this function value, right? And then I draw the tangent line and hit a little closer. I'm like, oh, okay, here's x3. Then what do? I find the function value at that and hit a little closer and hit a little closer. And the closer I get to my root, the closer the slope is going to be to the actual curvature of the thing, and the closer, and so it gets closer and closer and closer. And so you can end up estimating, and so you just use this little equation here, which is this little recursion formula, right? You just take the previous entry and you can find the next entry, and you keep doing this, and it should get closer and closer and closer to what the real root is here. Now, again, as I showed you before, I'll show you again. This can fail, right? This can fail. And so let me show you a case where this just kind of just doesn't work. So let me just have something comes up, comes down, comes up, comes down, comes up, comes down, right? And I want to know what's the root right here. And I'm going to just choose, and since it's really steep right here, I just choose some point x1 right here. Well, here, it's not that far from the root, right? It's really not. But here, if I follow the slope, I'm going to go this way. Hit some x2, and who knows, I might go from there, I might go this way. Right? And just totally miss it, right? Just totally miss the root. And just like start dancing around. So if you're not really close, right? If you're not like within some really nice range, it may fail altogether. And so you have to have a good first guess, right? You have to have a good first guess. And so this is a root finder. So let's actually just see it in practice. Let's see it in practice. It's actually not so bad once you crunch through the numbers, but let's see it in practice. And let's start with something a little bit easier. So this is a cubic, and cubic aren't too terrible with root. So here, we're going to start with x1 equals 2, and we want to find the third approximation of the root equation. So that means just basically run x1, x2, and x3 until you get to that. So let's remember our equation. Let me write it down for you. So it's x1 plus 1 will be equal to x to the n minus f, the function of x to the n, divided by the function derivative at x to the n. And these don't change. The only thing you change is plugging in the function. So do we know what the function is? Yeah, it's this. That's our function. What's our derivative here? Let's go ahead and crunch that real quick. So our derivative here is f of x. So this is my f of x. Is whatever the original function you set equal to 0. My derivative, well, we'll just take the derivative here. So we'll have 3x squared minus 2 plus 0. So that's it. And so for us, here we're going to have x of n plus 1 is equal to x to the n minus x to the n cubed minus 2x to the n minus 5 all over 3x to the n squared minus 2. And so we're going to start here. So we know what x1 is. They give us x1. It's equal to 2. So x2 will be found by the following. x2, so xn plus 1 will be found by finding x1 minus x1 cubed minus 2xn, or x1, 3x1 minus 2. Let's go ahead and bring that up. Now let's plug in what we know. What is x1? It is 2, right? So we just equals 2 minus 2 cubed minus 2, 2 minus 5 all over 2 times 2 squared minus 2. So everywhere I just say x1, I'm just plugging in 2. That's all I did from here to here. Let me just crunch this through. And let's crunch this through in our calculators. I'm going to just use Wolfram Alpha. And I'm going to use parentheses. That way I can make it really easy to do the next step. When you do multiples of these, it makes it really nice to do this in parentheses. So where I plug in stuff, I'm going to have something divided by something. So I'll go ahead and get that pre-prep for me. And then I'll have something cubed, which in this case is 2. So let me just go ahead and plug in the 2. Hold on, let me see if I can. Minus 2 times 2 minus 5, and this will be 2 times 2 squared. Nope, that's a 3. That's a 3. Did I write 2 over here like a doofus? Yes, I did. I wonder if doofus is one of the words I'm not allowed to use. I want to put it past it. So just plug it to, yeah, you just plug in 2 everywhere you see the x1, right? Because I give you, it gives you the initial approximation. So you just plug 2 in everywhere you see x1. Then why is it squared underneath? Oh, so here we have, so this is, what's on top is our function. So it's x cubed minus 2xn minus that. And on the bottom, we have our derivative. So it's 3x squared minus 2. Oops, I forgot a square here, didn't I? Okay. So here it is, so here I plug in x, and so xn would be 2, so there'd be 2 cubed. And then here it is 3 times 2 squared. Does that make sense? Oh, good. All right. So let's finish typing it in. I'll go back to my thing. All right. And the nice thing of only having 2 sections today is that we can do this slightly slower than usual. That way I don't, because this is, if you've never done anything numerical before, this seems a little bit weird, right? All right, we'll just go ahead and crunch that number for us. I don't think I inputted it right. Nope, I did not. Please check it looks correct. This doesn't look correct either. All right, what am I doing wrong? Oh, I closed the parentheses here. Why did I do that? Why did I do that? Here we go, right? Oops, I forgot something. What did I forget? I forgot the minus 2. Does this look exactly like what we have here? Let me double check. 2 to the third, 2 times 2, minus 5 times 3 times 2 squared minus 2. Yes, okay, so we get 2.1, right? So here we get x2 is 2.1. So what do we want to do now? Well, we just plug 2.1. So x3 is just going to, and I'm not going to, x3, we're just going to plug in 2.1 because that's what, and then minus 2.1 cubed minus 2 times 2.1 minus 5 over 3 times 2.1 squared minus 2. So the next, so whatever you get here, you just plug that back into where you saw parentheses last time, right? And now that's how you just do the next step. And so that makes it real easy. That makes it real easy. Thank you for helping me point out what I did wrong in the chat. So if you type it in this way, it just makes it real easy. I just go 0.1, and then I go 0.1. Everywhere you see a parentheses, you know to just type in the new number. And that's why I do it, even though it's kind of inefficient this way. That's why I do it this way. And so what do we get here? We get this really long result. You don't need this many digits. Just approximate it to a couple. So here I'm just going to say this is approximately equal to 2.0946. Okay. It's good enough, right? And so that's how you do this method. Is you take your function, set it equal to 0, find its derivative, use this equation, so it's just the function divided by it's the number, your guess, minus the function over its derivative. And then you just keep doing this until you achieve what you want. So let's do this again. Let's do this again. So why do we use this? So let's pretend I want to find, so you use Newton Mettons to find this to 6 decimal places, right? So it's the I don't know, the 6th root of 2. I don't know how to say that. I bet there's like some fancy way to say it, but I don't. So the 6th root of 2 is to say, actually, so how would we translate? We would translate that as x to the 6 minus 2 is equal to 0. Right? Because here, let's say x is equal to the 6th root of 2. Let me actually get you that point. Let me walk it. So that's also the same. So we're just going to walk this backwards. So we're just going to raise each thing to the 6th power, and then we'll just move the 2 over. Let me get this equation. So here we have some function, right? And what's the derivative of this function? Well, the derivative, so here we're going to call this f of x. And I want to get this to 8 decimal places. Okay? So this is my f of x. And then here, what's my derivative here? My derivative for this will be 6x to the 5th. And so finding this, finding what this is the same thing as finding this. These are the same thing, right? X, the 0 of this function will be what x is for this. And so these are equivalent. You'll do something like this, but these will have different numbers. You do the same thing, the same steps here. Okay. It says to 8 decimal places. So how are we going to find it to 8 decimal places? So let's just start with a guess. I'm going to choose a bad guess just so let's just choose a guess. Well, the square root of 2 is close to 1. It's like 1.4 or something, right? So the cubic root would be even closer to 1. So let's just guess 1. I don't know, just any guess would work. And so we're just guessing 1, because that should be really close to our solution. So we're going to run through Newton's method. So Newton's method in this case would be n plus 1 is equal to x of n minus, and then here, the function, our function here is x to the n 6 minus 2 divided by 5x to the n, no, 6x to the n to the 5th power. Okay, so this is our function, because here, what's my function here? It is x is 6 minus 2. What's my derivative of this function? 6x to the 5th. And so let's type in the first one. So x2, I'll type in the first one, and then we'll just go ahead and use the calculator to crunch through the rest. So x2 in this case is equal to 1 minus 1 to the 6th minus 2 over 5. Oops. Keep on 6 to the 1 to the 5th. And that is equal to, well, and this is really an approximate, so let's do an approximate. Let's type that in. All right. One. Our equation up here is to the 6 minus 2, so we don't need any of this stuff. And this is to the 6 minus, or times 6 to 1 to the 5th, and nothing else here. Boop, boop. And this should be a 1. Boop. All right, so I get 1.66667, right? Or 76. That's fine too. You can type in the exact answer. You can type in, since we're doing approximation, I'll go ahead and approximate it. We wanted to 8 decimal places. All right, so, or, oh, sorry, 1. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Technically, if I wanted to 6 decimal places, I should do it to 9 decimal places. So let me do it the way your book does it, so I don't get you confused. So this is 1, 2, 3, 4, 5, 6, 7, 8. So that's 8 decimal places. It'll probably have you type it in. That's too many sixes. I know, right? This is the devil's work. So I'll type in this into this. So now we use this approximation to find the next one. So here I have 0.16666. 1, 2, 3, 4, 5, 6, and a 7. And I'm just going to hit copy. I'm going to hit slam paste. I'm going to hit slam paste. And I get my next approximation here. All right, so let's just write that one down. And so this is approximately equal to 1.2. 1.1264438. That. Let's do x4. All right, so now what are we going to type in? Let's do x4. So here we'll have thank you. What I do? I rounded this to an 8. That's my digits. I hit copy because I don't trust myself with dyslexia. Paste. 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 Technically, we could do all this in Excel, and I could show you how to do it in Excel, but I find, are we supposed to be getting close to 0? I find you guys' Excel skills are not what they used to be. You put in, oh, you're absolutely right. Thank you. All right, so here we get 1.2249 49707. Let's just write that. Here we get, this is approximately 1 point. These just take a while, and that's why I'm kind of glad. That's why A was put alone, and B, you just took an exam. 49707. Okay. 1.2249077. All right, I'm going to copy that. Plug that in. So I want you to actually see how we do it. It just, like I said, these questions sometimes can take a hot second. So wait, you do 8 at a time? Yes, that's what your book is doing, and I want you to do the numerical way the book is doing. And the reason I say that is because when you do the online homework, if you type it in just one off, it's going to go, hey, I don't like that, right? All right, so we get this answer here. So we're at x5. So we get x to the 5th is approximately 1.1224625. I would love my in copy equation just put in so you don't have to retype. Yes, I thought that's really nice. All right, and let's go back and let's just type in the next one. Boop. 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 And notice how this one rounds to the same answer, 1.1224605. That rounds to the same one. And so what happens was what we say here is once we have two of them, once we've done this enough that, so this agrees to 8 digits, right? Or 8 decimal places, right? We stop. Okay, so you basically just keep running this over and over and over again until you get it to until it agrees and you hit stop, right? That's, you cut it there. Okay. And so some of your homework questions says round this to the nearest 8 decimal places. And so you just kind of just slowly do this and learn the numerical method. A little bit's busy work. I try to give you some stuff, not too much. And so if that makes sense, so you're going to keep running this until they agree, right? That means these are the same, right? It's 1, 2, 2, 4, 6, 2, 0, 5. So since these agree, you can go ahead and stop. And that's how you run most numerical techniques, is you're going to run. How do we come up with x1 again? I just picked a number 1 because square root of 2 is close to 1, and I wanted to start with an integer, right? That's how I picked it. Pick something close. Sometimes you'll look at a graph and guess, right? I think we'll use a graph next time to guess for us, right? Yeah, we'll use I'll show you the graphical method of how to guess. So let's do the next one so we can use that. All right, let me leave this up so you guys can copy if you need to. All right, so find correct to 6 decimal places the root of the equation. So what do we need to do? We need to set it equal to 0, right? I'm going to set this equal to 0, which isn't too hard. So we just hit cosine x minus x is equal to 0. So now we can find the root of this equation with the answer of this one. All right, so if this is f of x, what's our f prime of x? Our f prime of x here is cosine goes to minus sine x, and 1 minus 1. So here's our f of x. This is our derivative. And so here we can say our equation for this one is x to the n plus 1 is equal to x to the n minus our function value, which in this case is cosine x minus x, over our derivative, which is minus sine of x minus 1. And just to make our life easier, I'm going to do a little bit of algebra. By a little bit, I mean almost none at all. I'm going to just say x1 is equal to plus cosine of x minus x over sine of x plus 1. Just pull out the negative. All right, so what are we going to choose to be our first? Well, let's just graph it. Let's just graph it. Let's go to Desmos. Desmos. Thank you. I want to graph this awful function. I want cosine x minus x. Woohoo! Right? And so I'm looking for this point right here. So let's just for my ability to kind of explain what's going on, I'm going to choose 1. I know it's kind of bad, right? But it's a nice integer. And then 1, I'm going to use this slope, and this slope's going to slam really close into it, right? It actually will get super close to where I want to be really quite fast. And so I'm going to choose 1. Remember what the numerical technique does. It starts at this point, draws some tangent line, right? Draws a tangent line, and then figures out where does that end up being 0, and then chooses that for our next point, and goes in and in and in. And so it'll come in closer, say like hits here, it'll come to here, draw that into here, say that hits about there, it'll come into here and say, okay, it comes in there, hits about there, and comes in and comes in and comes in. So let's just choose 1 to choose something, right? Okay. Shouldn't it be cosine plus? Oh no, if I here it's I minus x from both sides to get the 0. Good question. So it'll be yeah, when I simplify. Yeah. You got it. You got it. And so here I'm just going to choose x1, and I'll do like the first one with you, and then I'll just pop you to the answer. All right, so here we're going to have x1. x1 is equal to 1. x2 is equal to 1. Well, in this case, it's equal to 1 minus, or plus, we're going to use this, cosine of 1 minus 1 divided by sine of 1 plus 1. Oops. And notice here I use the parentheses to indicate everywhere I have to input something. Okay. All right, so let's go back. Yeah, lead page. Go back, go back, go back to my little cheat sheet. Wahoo! So here we are. So this will be 1. This will be now cosine of 1 minus 1. Oops, this is now plus. And this will be sine of 1 plus 1. Okay. And notice how everywhere I'm plugging in something, I use the parentheses. And notice this one doesn't have a parenthesis on it because it is not where I'm plugging it in. It just is 1, right? This one is 1. The other ones were all technically x's. Oops, I did not put an x here. There we go. All right. All right, so let's go to this. So what do I get? I get I get this number. I'm not going to read it. I'm just going to write it. So this is approximately equal to 0.750363 87. Yeah, that's 8 decimal places. Okay. And then I'm going to do the same thing again, right? And now I'm just going to plug in 0.7 plus cosine. Let me make it very clear what's happening here. Cosine of that minus that over sine of that plus 1. And if I do that, I'm just going to use the pre-calculated ones. 0.73911289. And then here x4, if I keep running this through, would be 0.739085513. So how many does this agree to? This agrees with 1, 2, 3, and here it disagrees. So at 4, it's disagreeing. Let's go to 5, 0.790. And this one also is 0.851 or 53. So this agrees to 1. Oops, I forgot my 3 here. 1, 2, 3, 4, 5, 6. So technically we're done, even though it's 7 and 8. But since it agrees up to 6, so it agrees up to 6 places. We stop. Okay. And there you go. And so this right here would be our approximation. Okay. Oh, so this problem's at the 6 plus, yeah, so this one asks for 6, but for whatever reason your book, I'm trying to follow the method your book used, mainly that way you don't have problems on web design. Your book seems, as I'm looking through all of this, your book always seems to use 8 decimal places, right? For your approximation, and then 8, when your book is holding it, it's holding 8 decimal places, right? Um, so when you're approximating your numbers until you find it, use 8 decimal places, and where it agrees is how many points. It's how many when you look one above, it agrees. So if it's 7, 3, 9, 0, 8, 5. And as long as it agreed here, then let's pretend this was like a 3 or something, right? Instead of a 1. If it disagreed here, it still agreed to 1, 2, 3, 4, 5, 6 decimal places, okay? Will x1 always be 1 when we begin to find the rest? No. No, well, let me see if I can find something. Yeah, so one of the places in your one of the problems in the book is it's going to have like a cubic, and it's going to sometimes the book will tell you where to start, right? Um, like they'll specifically say x1 is -3, right? Um, a lot of times one's not bad, and sometimes they'll ask you to find multiple roots, right? Let me just type in something real quick. So let me just show you one of your homework problems without showing your homework problem, so I can leave it in the video and not have to cut to it, right? Let's go to, what am I up to? I want the Desmos. All right, so it's going to ask to find all the roots for this equation, and it's 7 to the 6, or x to the 6 minus x to the 5th minus 6 x to the 4th minus x squared plus x plus 10. Okay. Make sure I type that in. There is no cubic term. Yes. All right, so here's one of your homework problems, right? So find all the zeros of this puppy, right? So if we zoom all the way out, we indeed see that what we have here are the zeros, right? One of the zeros we're going to start at, we're going to look at 1, right? One will help us to approximate this 0 fairly well. It's a good place to start, right? 1 would be a great place to start for this 0. Here, a great place for this 0 is 3, right? Because that's really close to this one. So here, and then this one would be, I would use -2. It's really close to that. And here I'd use -1. So like for this one, I want to find 1, 2, 3, 4 zeros, because it says find all the zeros of this. Okay, up to 8 decimal places. This problem here is worth 6 points. It's worth 3 of your homework problems, right? Because you have to do it not once, not twice, but 4 times, really. So that's why it's worth more. Okay, and so here we're going to start at 2. But notice here that your equation for this will be, oops, I'll go back to this one. Boop. Your equation for this will be the same. You're going to, so your equation here would be, this is your function, right? This is your function. And then you find your derivative, right? You'll find your derivative, which is just 6x to the 5th. Yeah, and so this equation will look the exact same for all 4 points, right? Just one, you're going to start at x2, and it's going to crash into this point. One, you're going to start at x minus 2. x1 equals -2. It'll crash into this point. You'll start another one at x1 equals -1. It'll crash into this point. You'll start at x1 equals 1, crash into this point, and then you'll start the last one, x1 equal to 3, and it'll crash into that point. Okay? So even though what you're crunching through is the same number, your starting point tells you which 0 you're going to head to, right? Now notice here, if I plugged in 0 as my starting point, I'm just going to shoot off to Never Never Land, right? I'm just going to go wee, and it's just not going to help, right? So pick something really close, but I would pick a nice, easy number to start with too. Okay. So pretty much we're doing the whole process 4 different times with different x1s. Correct. That's exactly it, right? And the actual function you derive that you're plugging in the x1 isn't different. It's the same function, right? You're just going to do it. It'll just find different zeros depending on what your x1 is. Perfect. Does that make sense, guys? All right.